Hi, it's Adam, and today we're going to be talking about the ROT-13 cipher, which is a substitution cipher, basically just meaning that given a string of some kind, let's say hello world, you substitute each letter in the string with another letter. So like let's say you're going to shift each letter over by one space in the alphabet, you would get H, A, B, C, D, E, F, G, H, I, E, D, L, M, N, O, P, space, W, X, O, P, R, S, L, M, D, E. So this string here, IDMMP space XPSME, is the shifted version of hello world and has been shifted by one letter to the right. So this would be a version of the Caesar cipher, which the ROT-13 cipher is a version of the Caesar cipher. In this version here, this example, the shift was 1, shifting one letter to the right. In the ROT-13 cipher, we shift each letter 13 times. So A becomes 13 letters over, and so on. B becomes O, C becomes P, so on and so forth. So the Caesar cipher itself uses the basic Latin alphabet, and since the ROT-13 cipher is just a version of the Caesar cipher, it is also going to use the Latin alphabet, which consists of 20 letters, A through Z. So this is just the standard modern English alphabet, A, B, C, D, E, F, G, all the way through Z. And in the ROT-13 cipher, each letter is shifted 13 letters to the right. Really, it could be shifted 13 letters in either direction, either to the right or to the left. And that is what makes the ROT-13 cipher unique and why it has its own name and it's significant, is because since it is shifted 13 letters and the alphabet is 26 letters, that means that you are shifting it half of the alphabet, either to the left or to the right. So you get the same result either direction you go, which means that you can use the same algorithm to encode a message or to decode a message. So if I were to run hello world through the ROT-13 cipher, I would get not this, because we're shifting 13 letters. I would get some other encoded cipher here, and then I could put that back into the same ROT-13 cipher, and it would result in hello world. So you can use the same method to encode and to decode your whatever your message is, whatever the thing is that you are trying to keep secret. Now, it is important to note that the ROT-13 cipher really is not suitable for true encryption. If you're really trying to encrypt a message in order to keep it secret from anyone, the ROT-13 cipher and any Caesar cipher is really not a sufficient form of encryption, because they are, it's such a simple method of encoding your message, and it's so simple to revert that encoding. All somebody needs to know is, hey, I think that there is a Caesar cipher going on here, and so basically I'm just going to brute force this message to figure out what the decoded message is. And to brute force the Caesar cipher, all you have to do is shift by 1, see what message you get. If it's gibberish, then that's not it. Shift by 2, see what the result is. If it's gibberish, that's not it. Shift by 3, so on and so forth. You really only have to do that 26 times at most, and you will decode the cipher. So with that said, let's go ahead and jump right into making one of these ciphers in Python. And we are going to do that from in VS Code. So let me go ahead and make a file. We should be in the scripts directory now. So I can just go ahead and make my file. Let's call this ROT-13 YouTube.py. And now we are going to open that up in VS Code. All right, so here we are. Let's go ahead and get the terminal out of here. Now I am using the Vim plugin in VS Code. Still kind of getting used to it, but that is why there's a block blinking there rather than a line. So, all right. So what is this file? This is a ROT-13 Cipher encoder and decoder. Now this is really a very simple and straightforward cipher here, which is why I've chosen it as my first video to do. First we need the alphabet, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. And we're going to use a lambda function in this one. So lambda x, let's go ahead and set this to a variable. We'll call this code. In this code, this is going to be what we pass into it, whatever we want to encode or decode. So lambda x, we're going to use a list comprehension here. We're going to select the index of our alphabet, so for each letter, so in our lambda function, basically we're going to go through each letter, and whatever we pass into the lambda function, whatever our x value is, we're going to iterate through each letter, find the index of that letter in the alphabet. We're going to add 13 to that index, and then we are going to do a modulo 26 onto whatever that number is. So if adding 13 to our index is less than 26, then we're just going to have our then it's going to be unchanged. It's still just going to be whatever that number is that's less than 26. If it's more than 26, then doing the modulo 26 is going to give us the remainder. So let's say it's 27, then we do a modulo 26. We're going to get basically divide by 26 and whatever is left over, which would be 1. So if our if the letter that we were trying to find the result for was and added 13 onto that index, we got 27, did the modulo 26, we would end up with 1, which would be A. So because A is the first index of our alphabet. So that is basically how this lambda function is going to work. So we're going to take az.index of our letter, and we actually need to encase this in some whatever you call those, parentheses. So az.index of our letter, we're going to add 13 because that's what we're going for, and then we're going to take whatever our index is plus 13, we're going to modulo that by 26, and we're going to do that for each letter in X. All right, so that's our lambda function, and then basically we can just print, whatever the code is that we want. So let's go ahead and make string our variable, and we'll set string up here. We'll create some string. Let's call this hello world, super original. and let's see what we print out. So where are we here? Yeah, that's not where I want to be at all. ROT-13. Oh. Oh. Where did I open this? Is it just in my scripts file? Yeah, okay. So I didn't put it in the cryptography file, which is sort of what I meant to do, but that is a-okay. So we got an error. Let's see what we did wrong here. For letter in X. Okay, let's see what our error says. Substring not found. Just go ahead and pass a string into here. Oh, okay, I think maybe I just didn't save after adding. Huh, why is that? Let me see here. Some string equals hello. Some string. So this should work, right? Yeah, so that works. I think it's just maybe because I called it str. All right. Anyway, so if we pass in whatever our string is, hello, we get this result. So this is in a list format. So let's go ahead and join this together in our Lambda function so that we get it returned as a string. There we go. So URYYB is the Caesar ciphered version of some string, or of hello. So I think we can go ahead and actually like right now this Lambda function is not accounting for any spaces. So if I were to put hello world in here, then okay, so this is actually why I'm getting the substring error, is because I don't have any way to deal with spaces. So for letter in X, if letter dot is alpha, else let's return, or let's add just a space. So let's see if this works. Didn't actually test this. Yeah, okay, if letter is alpha. All right, so it works, but for hello world, but it doesn't do anything for the space. It just leaves HELLOWORLD. So it just doesn't add the space at all. So there's nothing there. So all of our words, hello world, how are you today? Go ahead and put, well, so if I put the question mark in, we would actually need a different type of cipher. We need to be doing the ROT-47 cipher, which I'm going to do in a future video, so we're not going to worry about that today. Right now it's just the ROT-13 cipher. I'm not accounting for these spaces, so we're going to see if we can figure that out real quick, because right now you can see this is what I am returning. So if I go ahead and copy this, what is returned from my ROT-13 cipher, if I put this into the cipher, you'll see we'll get hello world, how are you today, but there are no spaces. So for letter in X, if letter dot is alpha, dang, I feel like I should be able to put an else statement for letter in X, if letter dot is alpha, else maybe if I set space equals this. No. Okay. Else. Well, I'm not sure how to do the else in here. So that is not going to work out. For letter in X, which is in this case some string, if letter is alpha, there's got to be some way to add a space in there, but I'm just learning. I've just completed 100 days of coding, so I've been coding for 100 days total. Lambda functions are one of those things in list comprehensions that I'm just starting to get a grasp on. So I'm not sure how to do that, but that is basically the video for today. This is the ROT-13 cipher, a version of the Caesar cipher. We're going to be diving into Caesar ciphers, more different variations of Caesar ciphers. We're going to do the original Caesar cipher, the one that Julius Caesar used, which is not the ROT-13 cipher. And the intention is to do a video similar to this every day, sort of a walkthrough of some code or some aspect of cryptography or hacking or anything in that space, really just whatever I'm interested in studying. This is mostly just a series geared towards helping me learn, review material, solidify that material, and to grow as a developer. So the fact that you are here watching and listening is just bonus points, and I am very appreciative of that. So thank you for being here to be a part of this, and I will catch you next time.